Hi guys, hello everybody. क्या हाल चाल है भाई? Namaste. How are you guys doing? Please tell me hi if you are able to hear me properly. If you're able to hear me properly, if I am audible, please tell me a hi. Please write in the chat box that if you're able to see me and hear me properly. And telling you again, my name is Saurav, and we are now starting with our inorganic chemistry lectures for 12th standard. So 9:30, please do remember, mark your calendar that 9:30 every day will be the inorganic chemistry lecture for 12th standard. And 10:30 will be for 11th standard. So if you're in 12th standard, 9:30 is the time you join. 10:30, tell your juniors to join. Okay, 10:30, tell your juniors to join. So chalo, I hope everything looks fine at my end. So I'm a little new to this thing, so kuch mistakes ho jaye. If there are any mistakes, please do forgive me. And yep, the medium of instruction will be completely in English. People who are coming from northern part of the country or people are coming from the southern part of the country, please do remember that the medium of instruction will be completely in English. Okay, medium of instruction will completely be in English. Okay. Hello Ram Gopal. Hello Arvind. Hello Janardhan. Hello Shivam. Uh, Ram Gopal. Always the wall. Always the wall. Okay. Chalo. Let's start today's session and let's go ahead and see what coordination compound has to offer us. So, chalo, let's start today's work. And today's work is about the very first thing about coordination compounds. And this thing is known as Werner's theory. Werner's theory is the very first thing about coordination compounds. And in fact, coordination compounds is not a very old science. Somewhere in the last century, a little before last century, like towards the end of 19th century, 1890s, the work around coordination chemistry had started, while the work around coordination chemistry, work around other fields of science had started long back. Okay, work around the other fields of science had started long back, like atomic structure. They had been working on it for quite a long time. Gaseous state, electrochemistry. Faraday was already working on electrochemistry. So a lot of work in the other fields of science was already established, but nobody was working on Werner's theory. Nobody was working on coordination compounds. So this guy comes along, a guy named Werner comes along, Alfred Werner, and he starts investigating certain compounds that he finds very interesting. So let's start today's session about coordination compounds, and this is lecture 1. Okay, this is lecture 1. Now, if you look at compounds, your compounds can be segregated into acids, bases, and salts. So if I look at compounds, if I look at any compound, I can segregate it into acid, base, and salt. Most of the compounds I can segregate it into acid, base, and salt. When I talk about coordination compounds, this chapter deals with the salt aspect of a particular molecule. Why are we discussing it as a salt? You will learn this later. Acids are characterized by something which gives out I'll give you the answer, Siddharth. I'll give you the answer, Siddharth, that how things were discovered. So please bear with me. Okay, so things will go slowly. There is a chronological pattern that needs to be followed. So we'll follow that. So why salts? Because salts give ions other than H plus or OH minus. Acids give H plus ions, base gives OH minus ions. Salts will give cations and anions, but they will not be the same as H plus or OH minus ion. Now, why Werner was very interested in investigating these compounds is because there are like looking back, I feel, or every chemist feels that there are so many things around us which are in the form of coordination compounds. For example, you take hemoglobin. The hemoglobin, which is the oxygen carrier in your blood. Okay, hemoglobin, which is the oxygen oxygen carrier in the blood, contains iron. Magnesium is present in chlorophyll, which is the responsible for photosynthesis and sustaining the whole life on the planet. Okay, which is responsible sustaining the whole life on the planet. So you can see even vitamin B12 that is cobalamin. Okay, vitamin B12 that is cobalamin is contains cobalt. Vitamin B12, if you do not get vitamin B12, your nerves will become weak, your nerve conduction will become weak, your blood cells will not get repaired. Like if there is a illness and your blood cells are the RBC count somehow goes down, your blood cells need something to get repaired. They require vitamin B12, and if coordination compounds would not have existed, vitamin B12 would not have existed, and you would have suffered from that illness. You would not never recovered it. If you would not had hemoglobin, then oxygen could not have been transported. Okay. Yes, cyanocobalamin. Okay. Yes, cyanocobalamin. Hello, Sudhakar. Hello, Sudhakar. Okay. So please tell me if you understand that why learning coordination compounds is easy, because chemistry is a science of observation. If you observe something, you go after it. If I observe that there is a change, there is plastic, there is a polymer, there is something which needs to be enhanced, there is something which needs to be created, every chemist will go after it. Do you understand? Please tell me a yes if you understand that what is the need for studying coordination compounds, because coordination compounds, yeah, there will be daily classes. So there will be daily classes. Please don't get distracted. Let's maintain the frequency. Let's be in sync. Let's follow what is being taught. So do you understand this part, that why we need to study coordination compounds? Because they are so very profoundly present around us. In fact, there is a compound known as cisplatin, which is utilized in treatment of cancer. It's so cancer drugs, like anti-cancer drugs, one of the compounds is cisplatin. Now we start with the idea that most of us know about salts, and salts are classified into several categories. One of the starting categories is simple salts. So what are simple salts? Simple salts are those salts which when dropped in water will dissociate into their respective ions. For example, sodium chloride when is added to water will disintegrate into sodium plus and Cl minus. Aluminium sulfate, if Al2SO4 whole thrice is added to water, then I would be getting 2Al3 plus 3SO4 2 minus. So I'm getting all the ions very easily. So simple salts contain one type of cation and one type of anion. Okay, one type of cation, one type of anion, one type of cation, one type of anion, one type of cation, one type of anion. Okay, perfect. Let's move ahead. There are something which are known as addition compounds. What are addition compounds? Addition compounds are prepared by mixing two simple salts. So I know simple salts. What if I mix two simple salts and evaporate it or boil it? So evaporate it, boil it, I will get new substances. For example, I take copper sulfate and I combine it with ammonia. I will get a blue colored I would say a salt of, this will be blue, of copper sulfate .4NH3. Similarly, if I take AgCN and combine it with KCN, I will get KCN.AgCN. This is also a addition compound. Two things are getting added together. So when you mix two things together, they add together and it creates a addition compound. Similarly, if I take K2SO4, Al2SO4 whole thrice and I let it absorb some moisture, what I get is alum. What I get is an alum. Please tell me in the chat box that have you seen alum? Have you seen alum? Yes or no? Have you seen an alum? Please tell me in the chat box that have you seen an alum? Werner theory is important for the for JEE point of view. Is this because of intermolecular force of attraction? Exactly. Anything which exists must have had some intermolecular force of attraction. Yes, yes. No, you have not heard of it. So, alum is utilized to purify water. Purify water. It is white in color. Also, if any guy has been to a salon, okay, if any guy has been to a salon, you might have seen that those salons which are next to the road, and they keep a white colored, it looks a little watery kind of, it looks like a little covered with water kind of texture, and when the person applies it on the face of the customer who have just had a shave, okay, who have just had a shave. So they use you might if you go to villages, they still like use it as a aftershave. Okay, so yes, fitkari, yes, in Hindi it is known as fitkari or fitkiri, आप कुछ भी बोल सकते हो. Yes, fitkari. It is being made to stand in the entrance of houses. That I'm not aware of. I am not Sri Meenakshi. I'm not aware of that. However, I guess you now understand this. Let me give you a very like whenever I talk about fitkari, I recall an episode from my childhood. So my dad, we used to live in a very small colony. My dad took me whenever he used to go for a shave or for a haircut, he used to take me and my sister, because he used to go on a Sunday, and Sundays we wanted to go out. So what used to happen is that whenever I used to go there, I used to run around the place, and my sister used to run around the place. There's a nice small salon. Now the thing is that I was like about 7 years old or 8 year old, and my sister was doing all sort of like nonsense, and I just rebuked my sister. Maybe like I'd have pinched her or have done something. She started crying. So my dad came and asked me that, he told me that, there is a myth that people cannot take out their tongue without closing, while their eyes being closed. I was like, what is so problem with that? So so he asked me to close my eyes and take out my tongue, and like the moment I took out my tongue, he put that alum which was kept over there on my tongue. I was so embarrassed, but it just taught me a lesson that I should not mess with my sister in front of my father. Okay, so a beautiful anecdote, something from a childhood. So let's go ahead. What is an addition compound? Addition compounds are formed by mixing two salts together, and they are present together because they have some kind of attractive interaction. Okay, attractive interaction. Now, addition compounds are further subdivided into two categories: double salts, and coordination compounds or complexes. Let's understand what is a double salt. Now, what are the features of a double salt and how does it how it is different from coordination compound or complexes. So if you take a double salt, the most important feature of a double salt is that a double salt will dissociate completely in water, okay, to give all the ions. Let me just write this over here. So double salt gives all the ions. Double salt will give all the ions in an aqueous solution and does not give all the ions. Does not give all the ions in aqueous solution. Let me just, this does not give all the ions in aqueous solution. Let me just explain this, okay? Let me just explain this. What is the meaning of this statement? Suppose I take sodium chloride. How many ions would you be getting in the aqueous solution? Please tell me in the chat box. How many ions would you be getting in the aqueous solution? And how many ions will you be getting in the aqueous solution? Two ions. Very good. You will be getting two ions. You will be getting a Na plus ion and you will be getting Cl minus ion. If you take Al2SO4 whole thrice, you will be getting 5 ions. You will be getting 5 ions. You will be getting 2Al and you will be getting 3SO4 2 minus. Now, if I take K2SO4 dot Al2SO4 whole thrice dot 24H2O. Now remember, water does not dissociate. Okay, water does not dissociate. Water is a covalent compound. It does not dissociate too much to give cations and anions in appreciable quantity. But K2SO4 is a salt. Al2SO4 whole thrice is a salt. So if I were to identify how many ions will be produced, I will be saying that there will be 2 K plus ion. There will be a sulfate ion from K2SO4, 3 sulfate ion from, so there will be 4 sulfate ions, and there will be 2 Al3 plus ions. So in total I will be getting 4 plus 2 plus 6 plus 2, 8 ions. Okay, I will be getting 8 ions. Is that clear? I'll be getting 8 ions. However, so imagine you devise an experiment to detect these ions. You will have to do some tests for detection of K plus, and you will get the knowledge of K plus. You will get a positive result of K plus. If you do a detection test for Al3 plus, you will get a positive result for Al3 plus. If you do a detection test for sulfate, you will get a positive result for sulfate. However, if you take a compound like lithium aluminium hydride, you might think that if I add lithium aluminium hydride to water, I'll create an aqueous solution of lithium aluminium hydride, which is like a hypothetical scenario. Consider that if it is happening, then you would expect that I should be able to detect Li plus, I should be able to detect Al3 plus, I should be able to detect hydride. But no, this does not happen. It does not happen. Okay, does not happen. Please do remember that when you add any salt into water, it might it might disintegrate completely, it might not disintegrate completely. Lithium aluminum hydride is a substance which will not disintegrate completely. It will disintegrate to give Li plus and AlH4 minus ion. So you cannot detect Al3 plus. Please do remember that you cannot detect Al3 plus. At the max you can detect AlH4. Okay, Sachin, so try and understand, this is being added to water, and when something is being added to water, it will dissociate, and when it dissociates, it will produce ions. Depending on how many cations and how many anions are there, I can calculate it quite easily. But there are certain salts which do not dissociate completely. For example, you take potassium permanganate. If you take potassium permanganate, Siddharth, they are known as imperfect complexes, but we are considering those complexes which bothered Werner. Okay, we are starting with those complexes which are not completely disintegrating. So most of the coordination compounds, about like 99% of coordination compounds, do not disintegrate. Like hemoglobin does not disintegrate completely. Hemoglobin, if it were disintegrated, then iron would have been lost, but that is not happening. If you take KMnO4, you will expect that KMnO4 contains potassium, KMnO4. You will expect that potassium is there, Mn is there, oxide is there. I should be able to detect potassium, Mn, oxygen. Absolutely not. You will not be able to detect all three of them. You will be able to detect only K plus, and you will be able to detect MnO4 minus ion. Okay, so these kind of complexes, these kind of compounds in which all ions cannot be detected easily, turn out to be coordination compounds or complex compounds. Okay, coordination compounds, complex compounds. Now let's try to solve this question. Can you identify which ions will be produced in each case? Please give me an answer in the chat box, starting from the first one. If I take the first one, then the ions that I will obtain from it in the aqueous solution, will be 2K plus 2Al3 plus 4SO4 2 minus. How, Akanksha Yadav, then sir, how do we know that there is Al in AlH4? Because of certain properties that it will show. Okay, like try and understand that we cannot get all the answers right in the first class. So like when a doctor investigates a particular patient, then he has to look for the very preliminary symptoms. So these are the preliminary symptoms. Okay, we will not worry about what happens later. So doctor is not worried about what happens later, so he'll start with the preliminary symptoms. So Akanksha, let's start with the preliminary symptoms. Preliminary symptom is I am not able to detect AlH4, all if this cannot be detected. Okay, now ammonium sulfate Al, so I will be getting 2 units of ammonium ion, 2 units of Al3 plus and 4 units of sulfate. Okay, C option will give 2 units of K plus, 2 units of Cr3 plus and 4 units of sulfate. D option will give Fe2 plus, 2 units of Al3 plus and 4 units of sulfate. So you can see that 4 units of sulfate are being obtained everywhere. If I calculate the total number of ions, so 4 plus 2 plus 2, that is 8, 4 plus 2 plus 2, that is 8, 4 plus 2 plus 2, that is 8, but over here 4 plus 2 plus 1, that is 7. Okay, the number of ions can change, however the number of the total cationic species produced will have total, this cationic species that are being produced can be identified from here. आप एक चीज देख सकते हो that cationic species whatever are being produced have the total charge equal to the total amount of anionic species which is present. Okay, Ajita, we have just started the topic, so don't worry about it. Okay, don't worry about it. Clear? Don't worry about it. Let's move ahead. Let's take this question. It's slightly advanced, so let's read out this question. K2SO4 solution is mixed with Cr2SO4 solution in 1:1 molar ratio to give a test for Cr3+. However, this is a full stop. However, CuSO4 solution mixed with aqueous ammonia in 1:4 molar ratio does not give a test for Cu2+. Explain why. Explain why. This is a very important NCERT level question that can be asked in your board examinations, in your internal tests. So let's try to solve this. What it says is K2SO4 and Cr2SO4 whole thrice when it is mixed in 1:1 molar ratio. We have taken 1 mole of the first compound, 1 mole of the second compound. The product that will be formed will be an addition compound, K2SO4 dot Cr2SO4 whole thrice. And since there is more, there's an aqueous solution, I will get 24H2O. So this, as we just discussed, okay, as we just discussed, this will give K+, this will give sulfate, this will give chromium, and this will give sulfate as well. So we can detect this because the first thing, the solution mixed with Cr2SO4 whole thrice in 1:1 molar ratio is giving us, it is giving us what? It is giving us a, please tell me, it is giving us a double salt. It is giving us a double salt kind of a thing. Correct. Okay, it is giving us a double salt kind of a thing in which all the ions can be given out. However, if you take CuSO4 and mix it with ammonia, you will get in 1:4 molar ratio, you will get CuSO4 dot 4NH3. Will get 4NH3. Sorry. Dot 4NH3. You will get 4NH3. Okay. And this is a complex compound because it is present like this, CuNH3,4SO4. So Cu is present in, you can see that there is a square bracket. In all the compounds where an ion is present, metal ion is present inside this square bracket, it will not dissociate. It will not dissociate. Very good. The name of this compound is tetramine copper 2 sulfate, but we will learn about the nomenclature a little later. But the only thing that you have to remember is these ions can dissociate easily. This ion cannot, because if you recall yesterday's session, do you remember yesterday's session? We had talked about a tale of sodium and copper. Copper became too greedy and wanted to form okay, copper became too greedy and wanted to form I would say ionic bonds, but it gave away electrons and ended up settling with the non-metals to form a covalent bond. I had told you this, the greed of copper. Please watch yesterday's session. Please watch yesterday's session. Chalo. So let's move on to the next thing. So we start with Werner theory. Werner was so interested in identifying what is the reason they are not getting dissociated. Like, why is copper and like CuSO4.4NH3 does not give a test for copper. He was so interested in identifying that he started investigating certain compounds. And to be very honest, Siddharth, it will take some time. Just let the chapter develop. Okay, let the chapter develop. When you see a movie, the whole plot of the movie is not revealed in the first 10 minutes or 15 minutes. You need to give it some time. Okay, many movies reveal the important secret towards the end. So give it some time. Okay, you nevertheless have to watch a movie. Christopher Nolan's movies reveal the thrill towards the middle of the movie. Okay, so give it some time. You will be able to understand things slowly. Okay, so let's focus on Werner's theory now. Do you know in which year Werner actually gave his theory? Any ideas in which year Werner gave his theory? I'll give you a hint. It is in 18 something. In which year? In which year Werner gave his theory? Werner gave his theory. Please tell me in which year Werner gave his theory. Any wild guesses? Please tell me in the chat box in which year Werner gave his theory. 2020. how how can he give a theory in 2020 and we are also reading his theory in 2020? 1824, 1886, 1890s. 1890s is correct. 1898. No. 1890s incorrect. 34. 2000 absolutely not, man. Like, it's written 18 over there. Yes, somewhere about 1894. Okay, somewhere about 1894 Werner gave the theory. Okay, and it took some time for him to like develop it and publish it. So 1894 was the year, somewhere about 1894. You know what is so very special? Werner did everything. Werner investigated everything with a high degree of accuracy. Werner investigated everything with high degree of accuracy even before discovery of electron. Discovery of electron, which took place in 1896. So he was able to identify this. So he was able to identify what is capable of behaving as a coordination compound and what is capable of not behaving as a coordination compound even before the discovery of electron. So it is very, very vital to know that this man was a genius. I do not, any compounds, anything which exists is because of electron interaction, and even though he was not aware of electron interactions, he could make very, very valid judgments. Okay, very, very valid judgments. Please do not spam the chat box. Made of stone, teach in Hindi. It is impossible. This is an English channel, so we would not. There are students over here who come from all parts of the country, so we will teach in English. Okay, so just a moment. Okay, so what Werner did is he started investigating. So he started investigating complex of cobalt, chlorine, and ammonia. Okay, he started investigating he started investigating the complex of cobalt, chlorine and ammonia, and what the number of sources from where he could obtain these compounds. He found that these cobalt, ammonia, chlorine complexes, so this is known as a cobalt, ammonia, chlorine complex. And the number of sources from where he could obtain these complexes, he found that these complexes appear in three forms. These complexes appear in three forms. These complexes appear like this. Just a moment. These complexes appear like this. The complexes appear as COCl3 dot 6NH3, COCl3 dot 5NH3, COCl3 dot 4NH3. Okay, he was able to identify that these complexes appear in three forms. So he made certain predictions and he checked it with his experimental results. Okay, he made certain predictions and he checked it with experimental results. Understood? So he was able to source three kinds of cobalt, ammonia, chlorine complex, and he made certain he went ahead and made certain experiments with some pre-notions of his, with some preformed ideas of his. Okay, with some preformed ideas of his. Okay, so let's try to understand what were his experiments. So the first experiment that he did, okay, the first experiment that he did was reaction with silver nitrate. Reaction with silver nitrate. Tanuj Sharma, it is not important that the year is known. It is important to know that he gave it at a time. Even if I assume that it is given in 1824, is it given before the discovery of electron? Yes. Are all instruments which are used for identifying a structure right now dependent on the discovery of electron? Yes. So this man was a genius because he was able to identify the property of a particular compound or complex or behavior, structure, bonding properties even before the discovery of an electron. Okay, so let's focus on the experiment. You are getting deviated. So JEE will never ask you, or NEET will never ask you the year. JEE will ask you about this experiment, so focus on this. According to this idea that any chloride compound like sodium chloride, if reacts with AgNO3, it gives a precipitate of AgCl, and this is a white precipitate. It gives a white precipitate of AgCl. Okay, white precipitate of AgCl. Now, if you have learned a little bit about mole concept, then how many moles of NaCl is utilized and how many moles of AgNO3 is utilized? So for every mole of NaCl which is utilized, I am utilizing 1 mole of AgNO3. So depending on the amount of AgCl which is produced, I can identify how many moles of ions of Cl- were present. Okay, how many moles of ions of ions of Cl minus are present. Now, going by this argument, so if there is 1 mole precipitate of AgCl, then I can say that compound contains how many moles of Cl minus? Compound contains 1 mole of Cl minus. Compound contains 1 mole of Cl minus. Okay, is that clear? Compound contains 1 mole of Cl minus. If I am getting 1 mole of precipitate of AgCl, then my compound should contain 1 mole of Cl minus. If I am getting, so magnesium chloride will give 2 moles precipitate of AgCl, and so I can infer that the original compound gives out 2 Cl minus in aqueous solution. Okay, understood? Is that part clear? So MgCl2, if I take MgCl2 will produce 2 moles of AgCl precipitate, which means 2 Cl minus are in aqueous solution. Only then they are reacting with Ag plus. Okay, is that understood? It does not mean that it is limiting reagent. There is no limiting reagent when we are taking 1 mole of each. It just means that the number of Cl minus which are present in the aqueous solution will be equal to the number of moles of AgCl which is precipitated. Okay, number of moles of AgCl which is precipitated. The number MgCl2 will produce, if you take a solution of MgCl2, it will produce 2 chloride ions, and so I will get a precipitate of 2 moles of AgCl. Okay, perfect. Now if I take this idea, I hope you are able to understand this. If I take this idea and I apply this on these complexes that Werner has created, these complexes that not Werner has created, Werner has found. Okay, Werner has found. So what do you think? What do you think Werner would have thought in for each of these complexes? What do you think Werner would have thought of each of these complexes if he would have reacted them with AgNO3? He would have thought that since NaCl contains 1 chloride and I am getting 1 mole precipitate, MgCl2 contains 2 chloride and I am getting 2 moles precipitate of AgCl. So cobalt chloride, all of these three should give me 3 mole precipitate of AgCl. Isn't it correct or not? I should be getting 3 moles of AgCl. 3 moles of AgCl. That should have been my first thought. That would be my first thought, that there will be 3 moles of AgCl precipitate. Okay, there should be 3 moles of AgCl precipitate because all of these 3 contain 3. Okay. Yes, it is important for JEE point of view, man. Everything which I am teaching is important for JEE. I am not teaching anything which is not important for JEE. Okay. But in fact, the actual thing is some different. The actual thing is different. This is very, very this was very, very interesting for even Werner, that why this thing is happening. In fact, what happened is COCl3.6NH3 actually produced. So this was, I would say, this was expected. Expected means you expect that this will happen. You expect that this will happen. But in reality, COCl3 when reacted with AgNO3 gave 3 moles of AgCl. Werner was very happy that his expectation and his reality are alike. Expectation and reality are alike. But the moment he took COCl3.5NH3, his expectation and reality are different. His expectation was 3 moles of AgCl, while he ended up obtaining only 2 moles of AgCl. 2 moles of AgCl. In the next compound, he was even more shocked, because this compound he was expecting 3 moles of AgCl, but he ended up obtaining, only 1 mole of AgCl. Only 1 mole of AgCl. Understood? Only 1 mole of AgCl. So can I say that Werner must have thought something about this, that why he is getting this result? He must have thought something about this. So can I say that the number of moles of precipitate of AgCl correspond to the number of chloride ions left in the solution? So can I say that COCl3.6NH3 produces 3Cl- in aqueous solution? COCl3.5NH3 produces 2Cl- in aqueous solution, and COCl3.4NH3 produces 1Cl- in aqueous solution. So in this case, one Cl- is undissociated, and in this case 2 Cl- are undissociated. Okay, 2 Cl- are undissociated. Now this is very different. In 1800s it was very different, because everybody thought that whatever chloride is present in a compound should come out in the aqueous solution and should be precipitated, but it doesn't happen like that, and that is exemplified over here. Okay, can you see this? That COCl3.6NH3 produces 3 moles precipitate of AgCl, 2 moles precipitate of COCl3.5NH3, and COCl3.4NH3 produces only 1 mole precipitate of AgCl. So it was completely different observation from what was expected. Okay, so this is where we would end today's session. In tomorrow's session, what we would do is we'll continue from here. We will discuss how Werner took help of some more experiments to establish the fact that what would actually be the real structure of this compound. What is the real structure of this compound? Okay, what is the real structure of this compound? What other experiment? So any scientist would not do just one experiment. A scientist will do more than one experiments to see a repetition of data, to see a repetition of process. If a thought is being repeated, then whatever they are doing is right. So everything, if is getting repeated, every assumption, every logic, every hypothesis that is getting repeated, then they will say that yes, whatever I am predicting is right. Okay, whatever I am predicting is right. Okay, so what made them dissociate in 6NH3? What made them? Yeah, Amulya, all good things come to those who wait. So you will a lot of things will be revealed slowly. A lot of things will be revealed slowly. Just enjoy the lecture. Today you have learned that all chloride ions, if you can see in a compound, cannot be dissociated. Some will be dissociated, some might not be dissociated, and this is something that is new to you guys. So go back, read the relevant section from NCERT. Do come back tomorrow at 9:30 sharp, and we'll go from here for and onwards, and we'll try to learn what other experiments he did. Okay, I am not teaching anything which is not important for JEE. Okay, NCERT for JEE Advanced, Inorganic, yes, exactly. Okay, chalo. So I hope you enjoyed today's session. I hope you understood things which I wanted to communicate. If there are any suggestions, please do write in the comment section. Also, I teach a little slowly because I have been teaching the toppers batch for quite a long time now. I teach slowly because I want you to understand things from scratch. The moment I will increase the difficulty level, I should not, the transition will become, I do not want that the transition should become difficult. Okay. Ionic equilibrium, Pahul sir or me, we will be starting a little later. Pahul sir is the best judge for it. He is taking physical chemistry. I will be taking the inorganic section. Okay. So my 10:30 session is gonna start in a moment, in about 7 minutes from now. My 10:30 session is on the topic hydrogen. So 11th standard students, please do let them know that 10:30 session is for 11th standard. Please do join tomorrow, and do not forget to hit that like button, share button, and subscribe button. Also come tomorrow. Okay, chalo, bye bye guys, have a lovely time and wish you all the very best. Keep yourself safe, man. Keep yourself safe.